everyone, in this video we will be solving systems of three equations, and this is the second part. I will put the link of the first part in the description box below. We go over this problem right here. There are steps that we need to follow in order that we can solve systems of three equations. The first step is to eliminate x in the first and second equation. So what are we going to do here is that I'm just going to go ahead and label this as step 1 right here. So we are going to eliminate the x in the first and second. So by the way, this is the first equation, this is the second, and this is the third. So then we go ahead and write the first and second up here. The trick in order that we can eliminate the x is that whatever is the coefficient of the x, or the one that we want to eliminate, that's the one that we are going to, this 3 right here is the coefficient of x. So I'm going to multiply the second with 3, and there is an invisible 1 right here. So I'm going to multiply that by 1, and then again, multiplying by 1, doesn't really change the equation, but then I'm just showing you that I multiplied 1 here because in some of the equations it may not be 1 right here. So I'm just showing you the general way of doing it. So what are we going to do is we are going to distribute this 1 into each of the terms inside the parentheses, and the same thing for the 3. So we're going to distribute that. So then we go ahead and rewrite this as, after we distribute the 1, so the equation would come out 3x minus 3y plus 4z is equal to negative 23. And so we're going to multiply the 3 to each of the terms here. So that would be 3x plus 6y. That's going to be minus 9z is equal to 75. And then once we have already distributed that, we are supposed to subtract these two equations every time. So please remember, we always subtract this. I will put a minus. So then we go ahead and say that 3x minus 3x is 0. So that becomes a 0. Negative 3y minus 6y is a negative 9y. And then 4z minus negative 9z is a positive 13z. And we have negative 23 minus 75 is negative 98. So then we go ahead and move on to the second step. The second step is to eliminate x in the second and third equation. So we eliminated the x from the first and second. In the second step, we are going to eliminate the x in the second and third. So I'm just going to write the second and third equation up here. Okay, in order that we can eliminate the x here, it's pretty much the same thing. We are going to multiply the second one with 1, and then we multiply the first one with 4. So whatever is the coefficient of the second x, you're going to multiply to the first. Whatever the coefficient of the x of the first equation, you multiply to the second. And then again, we distribute distribute the 4 to each of the terms inside the parentheses, so that we can go ahead and rewrite this after distributing 4 to the first equation and after distributing 1 to the second equation. The equation would come out okay, just like what we did with the first step, we are going to subtract these two equations. Again, we always subtract it every time so that we can eliminate. So I'm going to subtract this. So 4x minus 4x is 0, so we can cross that out. 8 minus 8y minus negative y is a positive 9y. So I'm just going to write that as 9y right there. And then negative 12z minus positive z is a negative 13z, and that is equal to 75. So this is our equation from the first step, and this is the equation from the second step. Now we're ready to move on to the third step. The third step is to eliminate y using the equations from the first step and the second step and solve for z. So I'm just going to show the work on the side right here. So I'm going to label this as step 3. So we are going to use the equation from the first step. So I'm going to write that up here. So that is negative 9y plus 13z is equal to negative 98. And then the equation from step 2, that is 9y minus 13z is equal to 75. As you can see here, both of them have 9 on them. You can use the trick that we already did from the first part right here, where you are going to multiply this with negative 9 and negative 9 right there. But then there's a fastest way to do it. We can actually add these two equations right here. So once we add this, we can eliminate the y. So negative 9y plus y is a 0. So this is a 0 right here. And then we have 13 plus negative 13z is a 0. And then we have negative 98 plus 75 is negative 23. So then the equation is 0 is equal to negative 23. And this doesn't make sense. 0 is not equal to negative 23. What does this tell us? If both sides of the equation are not equal, we go ahead and say that there is no solution. So in this three systems of equation here, there is no solution to this, meaning there is no value of x, y, and z that can make these equations correct. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, there are steps that we need to follow in order that we can solve this systems of three equations right here. The first step is to eliminate x in the first and second equation. So I'm just going to go ahead and label this as the first step right here. So I'm going to label this as S1. So again, it's the first and second equation. So I'm just going to write that up here. Okay, so the trick so that we can eliminate the x in this two equations right here, first and second, is that we are going to multiply these two equations. The one that we multiply is the coefficient of the x. This is 1, so I will multiply the second with 1. This is 2, I will multiply the first with 2. And then we are going to distribute the 2 to each of the terms inside the parentheses. And the same thing for the 1, so that we go ahead and rewrite this as, that would be 2x plus 2y plus 2z is equal to 4. So I distributed the 2 to each of the terms here. Now, I will distribute the 1 as well. By the way, multiplying 1 will not actually change the equation, but I'm just showing you that it's 1 right here because, again, in some equations, the coefficient of x may not be 1, so I'm just showing you the general way of doing it. So we can go ahead and say that's 2x, just distribute the 1 right there, so that's plus 2y plus 2z is equal to 4. Again, in order that we can eliminate the x, we are always going to subtract it. So we minus this. So 2x minus 2x is 0. 2y minus 2y is 0. 2z minus 2z is 0. 4 minus 4 is 0. So we have 0 is equal to 0. Now, let's move on to the second step. The second step is to eliminate x in the second and third equation. So I'm just going to go ahead and write the second step right here, S2. So it's going to be the second and the third. So I will write that up here. Okay, so it's pretty much the same thing. We are going to eliminate the x. The trick to that is we multiply this with 2, we multiply this with negative 4. So pretty much the coefficient of the x's have been flipped around and we distribute. So the negative 4 will be distributed to each of the terms inside the parentheses, as well as that of 2 to all the terms inside the parentheses. So that if we distribute the negative 4 to each of these, the equation would come out. Okay, so what are we going to do to eliminate the x? here is that we are always going to minus it, subtract it. So negative 8x minus negative 8x is 0. Negative 8y minus negative 8y is 0. Negative 8z minus negative 8z is 0. Negative 16 minus negative 16 is 0. So pretty much we have 0 is equal to 0. 0 is equal to 0 makes sense. So then we can go ahead and say that the solution to this would be all real numbers. Okay, now please make a distinction between all real numbers and no solution. For all real numbers, it's 0 equals 0 because it makes sense. But for no solution, if both sides of the equation are not equal, then we go ahead and say that there's no solution. Did you get the same answer as this? All real numbers? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!